This is section 2.5, guys. It's measures of position. Okay. There are 5 numbers that you will be asked in the homework online to find when you do this section. And the 5 number summary are the median, which you already know, the minimum value, which you already know how to find, the maximum value, which you already know how to find, and there is another value which is called the first quartile and the third quartile, which I'm going to explain to you in a second. All right, we're going to show you how to find the first quartile, second quartile, and a third quartile of a data set using this example. So here are the travel times in minutes for 15 workers in North Carolina, chosen at random. Sometimes, guys, it's faster to do it by hand rather than putting in the numbers into the calculator, and that's why I want to show you how to do it both ways. So, chosen at random by the Census Bureau, these are the travel times for 15 workers. When you look for position, guys, just like the median, the value in the middle, you have to rank the data in order from smallest to largest. So we ordered the data right here. And let me show you how to find the median first of all, guys. Okay, where is the median? How many values do I have? I have 15 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think you still remember what I said earlier about the median. So if you have an odd number, 15, add 1 to it, it's 16. Divide by 2, that will give you 8. So the median is in the 8th position. 1, 2, 3, 4, 5, 6, 7, 8. That's the median. Okay. So median will be 20. Now let me tell you what the first quartile is, and it's called Q1. The first quartile is the middle position of the first half of the data set. Since the 20 splits up the data set into two, this is the first half, guys. And this is the second half. Can students tell me where the middle value of the first half is? So I like you to ignore the rest. Just ignore everything else and just look at this now.
The third 10, the one that's highlighted?
Yeah, because I have 7 values, guys. And then if you add 1 to it, will be 8. Divide by 2 will be the fourth one, exactly. This is called the quartile 1. First quartile. The median, guys, is called the second quartile. Okay, third quartile. Okay. Cover, just the first quartile along with the median, and then let's find, the half of the second half of the data set. I got 7 values, guys, so I see something in the chat coming. 30, I agree. I got 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 values, guys. Add 1 to it, 8, divide by 2 is 4, count to 4, 1, 2, 3, 4. Or you can do it manually, so this is a quarter 3. Okay. Minimum is the smallest value in the data set, which is 5. Maximum is the largest data set value in the set, which is what? 60. Now, first quartile has a label, guys. Sometimes he doesn't say first quartile. He asks you to find this. Q1. Second quartile, median. It's called the Q2. It's right at 50%, halfway through the data set. And the third quartile, guys, is Q3. And if he asks you to find the 5-number summary, you add the minimum and you add the maximum, then you have what we call the 5-number summary. Okay? Let's do another one right here. Finding the 5-number summary. Here are the travel times to work for 20 New Yorkers. Okay, so we got 20 guys, and we need to find the 5-number summaries. Okay, if you have 20, divide 20 by 2, you get 10. So your median is located between the 10th position and the 11th position. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median is in between. This is the median right here. It's not 20 and it's not 25. Your median is 20 plus 25 divided by 2, halfway through, which is 22.5. Here you go. Now let's find, guys, the first quartile. The first quartile, this is the first half of the data set. I have 10 values right here, guys. So what do you think the median is of the first half? It's between the 5th and the 6th value. 1, 2, 3, 4, 5, 6. So between 15 and 15, which is 15. There you go. Let's look at the second half. And don't worry, this is all can be done using calculator if you want. I'm going to show you after I'm done with this example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's between the 5th and the 6th. Watch, guys. 1, 2, 3, 4, 5, 6. So it's between 40 and 45. That's a Q3. So 40 and 45 will be 40 plus 45 divided by 2, which is 42.5. Minimum. It's the lowest value in the data set. It's 5. And maximum, which is 85. And now it's the calculator turn to show you how we could do this using the calculator. Okay, let's do it. So stat edit, I'm going to clear the lists before I show them to you. All right, L1. So I'm going to enter the data values, guys. You don't have to enter them in order. If they don't give them to you in order, that's fine. But I'm going to use this example. So let me just enter the data.
How do you clear the calculator on it?
Okay, here's how you clear it. Let's say I have some values. That's a good question. Okay, you have some values. Look what you do. Watch. Select L1 and hit clear. Let me show you the clear button right here. And press enter.
Thank you.
And bingo, done. 5, 10, 10, 15. Keep an eye on me, guys, just so I don't make a mistake. Yeah, the second half of the data set now. I'm just copying the data. 25, 30, 30, 40, 40. I know we did this, guys, but I'm showing you how to do it using the calculator. There you go. Now I'm ready to show you how to find the 5-number summary without doing any work. Just put in the data into your calculator, go to stat, calc, one variable statistic. This is mainly, guys, the only function that we use in this chapter. One variable statistic right here. Okay, my data is not in L2, it's in L1. There you go. Okay. This is the mean. He's not asking for the mean here, 31.25. This is the standard deviation, guys, S28.87. He's not asking for it, but this is what he's asking for. 5-number summary. Minimum is 5. Q1 is 15. Look, so far is good. 5 and 15. Scroll down. Median is 22.5. Look, we got 22.5. Next, Q3. Q3 is 42.5. Look, we got 42.5. And I think you can guess what the last value is going to be the maximum, which is 85. So your calculator can do this. Now, guys, look at this data set. Do you suspect that any of the values there is an outlier? Is there some values or one value that stands out to you guys and appears to be an outlier, doesn't belong there? If there is such a value, what would that be, guys?
85.
85. Your suspicions of 85. So, this is going to take us to the next part of this, where we're going to learn how to tell if a value is an outlier or not an outlier. So you suspect probably 85 is an outlier. You cannot say it looks odd, it doesn't belong there, it's an outlier. There is a technique. And now I'm going to show you a technique, guys, on how to find out whether 85 is an outlier. Maybe another students will tell me, Mr. Bazi, I think 5 also is an outlier, probably. But let me show you the technique, guys, and how to find out if a value is an outlier or not. This is the one that you need to learn by hand, guys, because the calculator doesn't know, doesn't tell you. So you need to learn how to do it. And it's easy. Let me show you how to do this. So check if the data set has any outliers. There are a few steps. I'm going to write them down, guys, and then we'll figure this out. First of all, guys, you do Q3 minus Q1, which is called interquartile range. So there is a couple homework questions. He asks you to find the interquartile range, just Q3 minus Q1, as simple as that. It's called IQR. And what would that be, guys, in our case? It will be 42.5 minus 15. We've already done the work, which is 27.5. Yes? That's step number 1. I'm going very slow just to make sure that you can repeat the steps if you are asked to do the same question. But to check for outliers, guys, you need to find the 5 to have the 5-number summary. That's for sure. You need to have the 5-number summary and rank the data you notice in order like we did here. Step number 2. Multiply the IQR that we got in step 1 by 1.5. Always 1.5. This number doesn't change. So 1.5 times 27.5. What would that be, guys? You can simply use your calculator, doesn't matter. 27.5 times 1.5. I got 41.25. One more step and I'll be ready to tell you which one is an outlier, if any. Probably there are no outliers, we'll see. Take Q1 and subtract the number you got in step number 2. And take Q3 and add the number that you got in step number 2. What is Q1, guys? We did it already. It's 15. This is Q1. This is Q3, and this is Q2. So I got 15 minus 41.25. And then take Q3, which is what? 42.5 plus 41.25. And that is 83.75.
Professor, can you just move up the sheet?
Yeah, definitely.
Thank you.
There you go. And 26, negative 26.25. I'm done, guys. Now I'm going to do this, and I'm I'm going to ask you to guess, how do I figure out if there are outliers? Now I just have to look and see if there are outliers. Any guesses? What do I do with those two numbers that I got to figure out if there are any outliers? Make a guess, guys. You don't have to be correct. It's okay.
Add them together?
No. Just want you to look at him and look, I put something from to. That's a hint. Any numbers that are between those two numbers are not outliers. Any number that are outside the range of those two numbers are outliers. Are there any numbers that go beyond 83.75 in the data set, guys?
85. The last.
Yes, 85 is an outlier. As long as the numbers are between those two values that we came up with, they're not outliers. So if some students were wondering about 5, well, 5 is not outlier, guys, because it's within the range. The only one we missed, almost, you just look, we were not even going to miss it, but we did. 83.75, well, actually 85 is bigger than it is an outlier. So the steps, guys, subtract the two values, Q3 minus Q1, whatever you get, multiply by 1.5, that's what I got. Take Q1 and subtract the value in step 2, take Q3 and add the value in step 2, and then you get two numbers. Any values in the data sets are between, that are fall within the two numbers here, between the two numbers, then they're not outliers. Any values that fall outside of the range are outliers, and then we got one outlier in here.
I have a
Or-
real
Yes.
question. So where did you get the 1.5 from?
Oh, the 1.5 is a standard. You just have to use it. It's beyond the scope of the course to explain it, but if you just want to have an idea about this, we know a data set can go beyond the 3 standard deviation, because anything beyond that is outliers. And then the 1.5 is half of 3. This is where it came from. But you will always use 1.5, regardless of that question I ask you, it's a 1.5. All right, guys. So that concludes the outliers and the 5-number summary. What I'm going to do, I'm going to give you the break right now, guys. So let me